A very good morning, everyone. Thank you so much for joining today's Redington working session. The topic for today's session is applying digital innovation for modern application. The session will be presented by Ahmed. During the session, if you have any questions, please put them in the Q&A tab on the left, and they will be answered at the end of the session. Ahmed, over to you.
Thank you, Rakesh. Good morning, everyone. Today we are going to discuss about digital innovation and how you can apply digital innovation for modern applications, right? So let's start. So let's understand about Amazon's innovation approach. What approach has been followed, how they innovate, how they quickly come up with so many services so quickly, right? So there has to be a mechanism. So the mechanism is encoded behavior that facilitates innovative thinking. So they really think from a customer's perspective. They just don't launch a service for the sake of it. They think about customer. They understand customers' requirement. Based on that, they come up with services. So another innovation approach is the architecture. So the underlying architecture is really strong, and it can support massive growth and change, right? So they do architect the services in such a way that it can support a rapid growth and change when it comes to data. Third thing is culture. So with Amazon, the culture is they are customer obsessed. So when we talk about customer obsession, I mean they really think about customers' requirement. So they work in a backward, they follow a backward approach where they go back to the customer, understand what are the challenges they are facing in the current in their infrastructure, and then they launch a service. So they hire builders and they let the builders to build their application and support them with a belief system, right? So they don't tell what to build. They hire builders who can build a system and they support them. The last approach is organization. So the way they organize team is very important because they don't have such a big hierarchy structure. So when we talk about team, it's a small team that has complete ownership about of a service. They own end-to-end ownership about a service. From release to launch, everything is under their control. So we'll discuss that in detail in the upcoming slides. Let's talk about mechanism first. What mechanism is followed by Amazon? So as we discussed, the mechanism is working backward with frequent press releases and FAQs. So working backwards means going back to the customer, work backwards from the customer, go back to the customer, understand what are the challenges they're facing and what services has to be enhanced. Let's say if a service is already launched by AWS, what enhancement they need. So they really take customer feedback really seriously. On top of it, they release frequent press releases, so which actually provides you detail about the recent launches. If there is anything new happening on the platform, they will issue a press release. There are FAQs available for almost all the services. So they maintain a good FAQ databases where they put all the frequently asked questions in a page, and people can go through and access that page. The last point is user manual. They have very well documented. They follow a very well documented slide. So, like let's say we will find Amazon documentation really extensive. So when you go into the documentation, you'll find a detailed description of each and every services, how to do, what you can do with the services, what steps you need to follow. So user manual is very important, and this is something which they maintain uh, at a greater depth, right? So we talked about organization. Let's check organization in greater depth in this slide. So if you remember, the way AWS organizes their team is not in a heavy team of, let's say, 500 developers or 1,000 developers with project managers. No, they make small teams. They call it as a two-pizza team. So the team who can finish 2 pizza. That's the logic. So roughly, you can say there will be 8 to 10 people in the team, and they have full ownership. They have full accountability, and they focus on innovation. They follow DevOps paradigm. When we talk about full ownership, they are responsible for a service which they own. They are responsible for a service which they are developing, and they have full accountability. They want to make if they want to make changes, they don't have to check with the other team. They own that service. They can make changes, and it's fully accountable, right? So what is the advantage of 2 pizza team? First of all, as you can, it's very obvious. So they don't have to depend on other team, for example, for approvals or anything. They have full accountability and full ownership, so they can make whatever changes they want. They can follow whatever paradigm they want to, right? So with DevOps, a lot of things can be automated as well. So that's again, I think, with a cake. So this is about 2 pizza team. Let's talk about architecture. So the way Amazon is built, it's built in such a way that you can run very large application on the platform, and it can support your application requirement. So this is a statement from Jeff Bezos. We are creating powerful self-service platform that allows thousands of people to boldly experiment and accomplish things that would otherwise be impossible or impractical. So it allows you to fail. That's the beauty of the platform. So uh, let's talk about any other platform. Let's talk about your on-prem environment. So there is a limit of failure, right? You can fail once, twice, but then you'll say, no, it's not working, it's not happening, so let's follow another approach. But in Amazon, you can do repeated testings, you can do repeated deployments, and if you fail, you can just scrap the environment. That's not a challenge. So it's designed for failure. So you can fail as much, you can fail multiple times, but end of the day, you should be able to deliver the application that you want, right? Rather than making trade-offs. So that's the beauty of the platform. It allows you to fail, and it allows you to take bold decision, right? uh, Without worrying about the infrastructure and underlying cost. Other thing is, you can make, let's say, if you have to go back, or if you have to reverse the whole cycle, and if you have to go back to a previous version, it's very easy with AWS. So you just have to go back to a previous version, and then you're up and running. The culture, again, it's very important. So in AWS, they hire builders, and they let them build. So it's not like a top management says, okay, you have to build following services. It's not like that. They hire builders, they let them build whatever they want to build, right? Which can solve a real world problem. That's important. That's the culture part of Amazon. All right. So this is a statement from Jeff Bezos again. So this, what he said, we'll make bold rather than timid investment decisions where we see sufficient probability of gaining market leadership advantages. Some of these investment will pay off, others will not, and we will have learned another valuable lesson in either case. So they really encourage, bold thinking. They really give full authority to their builders, and they let them build whatever uh, they want to, provided it solves a real world problem, right? Now we'll talk about foundations of modern application portfolio. So we'll address what are the needs of modern application, how application has actually evolved. So if you remember previously, the application runs on a single data center and you'll be fine. But now the application has really evolved. It has become global. So similarly, the innovation has to be added in the application so that it can meet uh, the requirements. So we'll address that part in the upcoming slides. So we'll talk about foundations of modern application portfolio. So modern applications have new requirements. So there can be millions of users, more than millions, sometimes even billion, right? So system has to be defined, or an application has to run in such an infrastructure that can support millions of users. We are talking about petabyte and exabyte of storage now. We're talking about volume of petabyte and exabyte, right? No more TBs. So locality is global. So again, you have users accessing your application from number of locations. So so again, the innovation has to be added so that application can be served to global audience uh, with the best performance. When we talk about latency, it can be millisecond to microseconds now. So application has to launch really, really fast. Request rates can be million. So we have millions of users, making requests to our application. So request rate is millions now. So access types, so users will come from a variety of devices. It can be web, mobile, IoT, you name it, and other devices. So that also has to be addressed. And sometimes the application will needs to scale up and down very, very quickly. So if you have run a campaign, millions of users will come to you and use your application, but on a next day you might not have that many users accessing your application. So it should be scalable. So the application should be able to scale up or down, or in and out, and on demand, right? So for modern application, we don't want to make such a huge investment, because investing on an exabyte of storage upfront would be a huge cost, or preparing an infrastructure for 1 million users would be a huge cost. So we want to pay for what we use, right? Not making an upfront commitment. And developer access, no assembly required. So they don't need an assembly or anything. So developers need agility. Right. So how can we apply innovation and meet all those requirements? So to answer that, our architecture foundation has to be really, really strong. So then only we can meet modern day application requirement. And this actually boils down to 5 pillars: the architecture pillar, the data, delivery, operations, and security. These are the 5 pillars which particularly we need to address to make sure our foundations are really, really strong. When we talk about architecture, the traditional monolithic application architecture will not apply. The application has to be delivered very, very quickly. The updates are very frequent now, right? Because any new feature that comes into your application, you want to roll it uh, in a day, not in a month's time, right? So monolithic application architecture will not work. So we have to make a transition to microservices, which we'll see in the upcoming slides. Again, the data requirements are significant now. So the data has to be decoupled and purpose built. So you can't have one size fit all rule apply to the data layer, right? So you should use data which is actually needed by different application layer. For example, you might use SSDs for running your application, but you might use a cost-effective, throughput-optimized storage for running analytics, right? So different data has to really evolve, and data layers has to be evolved, and it should be decoupled and purpose-built. Similarly, when we talk about delivery, so delivery has to follow a principle, has to follow a pattern. The delivery cannot be on an ad hoc basis, right? And delivery should be automated as much as possible. So minimal user intervention should be needed, because we know whenever we have human intervention, we can have errors. So we want to automate as much as we can. Now the operations pillar focuses really on operations excellence. What are we tracking? What are we monitoring? How our resources are allocated? Are they allocated properly? So those questions will be addressed in the operations foundation. And security, of course, it's a very important pillar, and security is the first thing that we should think about whenever we think about our application. So security is everybody's responsibility. We'll see these pillars in the upcoming slides, and let's go through it. So architecture, let's talk about architecture. So what architecture pattern we should follow for the modern application? So the bottom line is it should be loosely coupled system and it should be designed for failure. Now, what is loosely coupled? Loosely coupled means we are avoiding dependencies on of one component on another component, right? So one component should not depend on other component, or if one component fail, it should not bring down my whole application, right? So if even if my one of my services fail, the others should respond and the application should be up and running. Only, let's say, if there is a problem in one of the service, then that service should be inaccessible. This should not affect any of other application functionality, right? That's the meaning of loosely coupled. And we should design for failure. So we should consider that application might fail. So how do we address those concerns? So this should be part of our application architecture. One very common misconception that people have, that when we deploy anything in cloud, automatically it's redundant. That's true for most of the managed service, but when you do not have a managed service, or if you're running your application on a normal VM, it's an instance, right? And it is deployed in an AZ. So you should really design for failure. So if we remember, like 10 years ago, we followed monolithic architecture, where there's one application, it does everything. Uh, if we talk about an e-commerce application, it uh, it processes your bill, it keeps track of your inventory. Everything is under a single application, single monolith, and it does everything. Now, in today's world, we focus more on microservices, where uh, we created different services and a different team own that service and they are responsible for maintaining those services. So with microservice, it does one thing and it does it well, right? So that's the approach we follow. The microservices anatomy is again very important to understand. So we can have users coming in from different devices, mobile client, web client, or from a desktop. It can be from IoT, and they will make an API calls, right? And this API can connect to the microservices, and the microservice can store persistent data into our backend database systems. So an event also can, if you see here, an event also can trigger an API, and these microservices, can it's independent of other. So an events again can trigger an API, and again a backend microservices can be called, and the data can be stored. The persistent data can be stored in the backend database. So the idea here is we are creating multiple independent services, so which does not affect the whole application. So and if we talk about troubleshooting, it's very easy to troubleshoot. So if we have a problem in one of the microservice, we can check with the relevant team and we can address those issues. But if we talk about the whole monolith, it's very difficult to troubleshoot, right? So if we talk about microservice architecture, how does this fit in Amazon, in AWS? We'll look into that in this slide. So we have users coming in from mobile applications, website, and other services, which is regional API endpoints. The first point would be CloudFront. So CloudFront can again integrate with your API gateway. API gateway will have API gateway cache, right? And by the way, CloudFront will cache. It's for caching. So your static contents and everything can be cached in CloudFront. And you have API gateway, which can be fronted by your Lambda function or endpoints on an EC2 instances. That can be fronted by either of them, or it can be front-end with your VPC. So let's say if you have Lambda function deployed inside your VPC, you can connect privately to those via VPC endpoints. And the API gateway again can integrate with other publicly accessible endpoints and other AWS services. Now we have a logging system. So with CloudWatch, we can get real-time statistics. We can actually store logs related to API gateway. We can send those logs to CloudWatch. So the monitoring aspect of the whole architecture comes here in the CloudWatch. So this is about microservices architecture. Now let's talk about data. So in data, we discussed about decoupled and purpose-built. What exactly is it? So I just gave you an example, but in this slide we'll go in depth. What are the modern application requirements in terms of data? So common data categories and use cases are mentioned in this slide. So our application might need a relational data or a key value pair, a key value data, a document database, in-memory database, or a graph-based database, time series, ledger. What are all these, right? So with relational database, when we talk about relational database and relational data category, it's actually referential integrity. It supports asset transaction and schema on write. What are the use cases? Probably some of your very common ERP application might use relational database. If you're doing a lift and shift of your application from on-prem to AWS, then you might go with the relational database, or some of your finance application may use relational database. Oracle is a name comes to my mind when we talk about uh, a finance or a CRM or an ERP based application, right? So it uses relational database in the backend. So key value data categories or key value databases, what are those? So with key value, you'll have high throughput, low latency read and write, and there is an endless scale. It scales automatically. So what could be the use case? So it could be real-time bidding, shopping cart, social product catalog, customer preferences, and many other. Gaming could be one example, right, for key value databases. You might need a document database to store documents and quickly access querying on any attribute, right? It could be a good use case for content management, personalization, right? You might need in-memory data category or in-memory databases, and you want to query by key with microsecond latency. When you really need a fast access, a quick access to the data, you'll go with in-memory databases. And this could be leaderboard, real-time analytics. So real-time analytics, as you know, the data has to refresh very fast, so you can't afford latency. In this case, you'll go with in-memory databases. You might need a graph database or a graph data category, so to quickly and easily create and navigate relations between data. So if you have a data set 1 and data set 2 and you want to create a dependency map or a relationship map between those two data sets, to visually analyze it, you would need a graph database. The use case could be fraud detection. So if you're tracking all the changes, you want to know, you want to use graph database just so that you can visualize it properly. Or social networking recommendation engine could use graph databases. You might need time series databases. So what it does, it collects, store, and process data sequenced by time, right? And this becomes very important with IoT application. You might want to capture the timestamp for IoT application, event tracking. Similarly, and these are, by the way, some of the data categories, right? You might have many other, might, mostly it covers 90% of the data category, I would say. You might need another 10% of it for object storage and all. And AWS do have services for other data categories, right? You might need ledger data categories. This could be a good fit for, let's say, blockchain application or healthcare registration or financial application, where actually you want a verifiable history of all changes made to the application data. So you would need ledger data basis in this case. Now, how does Amazon addresses all those data categories requirement? Let's find out. So we talked about purpose-built database. So AWS has databases for all your requirement. The relational database, AWS has Amazon RDS, which comes with Aurora and the Community Edition, Commercial Edition. All the databases are supported. You talk about SQL Server, Oracle, MariaDB. They all are uh, so you can create an RDS instance for let's say cache. You have Amazon Q series, you have timestamp, and Ledger you have LDB. Uh, now let's talk about software. So automating the delivery uh, we talk about as they are rolling in a daytime, week time, very developers will build their service and they will have their own delivery pipelines, right? So when we talk about pipeline, what is it? So pipeline goes through steps or the sequence. So the first step would be to build your code, right? And to test your code. And then you will release the code, and of course you will monitor what you have built, right? So there is a sequence, and it's actually very common for most of the application: build, test, release, and then monitor. So what microservices did, so we now have different set of services, and a team of developers are responsible for managing their own services. So they are no longer dependent on other services. They have full control of on what they are delivering. They have full accountability, and they can build, test, release their own pipeline. So this really, encourages uh, parallel development, I would say, because multiple teams can work simultaneously. They are not dependent on any other team, so they can work independently, sorry, and they can deliver code through their own delivery pipeline. So this really expedites the whole process and the whole cycle, and the release, uh, the codes can be released very, very quickly. So we talk about delivery pipeline services, but how does it maps to AWS? Let's find out. So when we talk about delivery pipeline, the pipeline in AWS is maintained through AWS code pipeline. The source code is stored in AWS code commit. If you know Git, so this is a Git equivalent of AWS, but with lot of advantages. So it supports Git command, but in Git you may have to buy different plans for your if you're an enterprise, but no, in code commit it's not the case, right? So building is another phase. So for build and test, you can use code build, or if you are using, let's say, third-party tool called Jenkins or any other, this also can be used along with code build. For deployment, you can use code deploy, and this can deploy the changes to your backend EC2 instance or to your Elastic Beanstalk environment. And the whole process, or the whole pipelines can be monitored via AWS X-rays. So it gives you hop by hop analysis of what each step is doing. And if there is any bottleneck in any of the steps, or if there's any performance lag, you can easily identify this with AWS X-ray service. Now, if you see the pipeline, it's called CI/CD, continuous integration, continuous delivery. So the CI part is actually build, test, and deploy, and the other aspect monitoring comes under CD. So this actually is a CI/CD pipeline. So by following this paradigm, by following this approach, we can easily see how quickly we can roll out an update, or how frequently we can release our application updates. This is a very good and very standard practice now. People who are working with microservices, they do follow uh, these principles. Now we also talked about operations part, right? Remember when we talk about the foundations of a modern application, operation was one of the pillar. So with operations, what do we mean? We mean we should be able to automate provisioning of resources. We no longer have to go to console and manually create resources. No, we don't want to invest time on that. We want to automate as much as possible, right? And we want to create a self-service AWS foundation. So people will have it will be like, whatever you want, you can go to a self-service portal and you can get that. And you want to implement monitoring tool to drive operations excellence. That's the core of operations, right? If you can't monitor, you don't know what is happening and how good are you meeting your SLAs or not. So there's no guarantee. So monitoring is a very important aspect of operations. Now, how do we address this in AWS? So we talk about self-service capabilities. So in AWS, we provision everything inside an account, right? So we have an AWS account and we provision all the resources, and whatever resources, services we need, we do that inside an account. And that account should follow certain security principles, right? For example, user authentication, multi-factor authentication, integration with the directory service, right? Um, Strong password for users, right? So those are some basic functionality which an account should have, and to do that manually could be a challenge if you have multiple accounts. So what AWS did, they come up with a concept called landing zone, and which automatically establishes guardrail for governance. So bare minimum security policies would be automatically uh, configured, or automatically provisioned for any new account. So it establishes guardrails for governance. For example, logging system would be enabled for all the account. CloudTrail logs would be enabled. Configuration, AWS config would be enabled for all the account. That we can define inside a landing zone configuration. And then you can have centralized identity and access control. And you can automate compliant and account provisioning. So with centralized identity access, what are the advantages? The advantages is, if we have multiple accounts, we can use a single sign-on to log into those accounts, because it's very hard to remember the username and password for each and every account, right? So we want centralized identity and access. Similarly, we want to automate compliant account provisioning. So if we need to provision any new account, we don't have to do it manually. We can do it from central. We can do it from a centralized account. We want to automate the account provisioning as much as possible, right? So with operations, I mean, we should be able to enable agility and governance also. So what do I mean? So I mean, I should be able to set up best practices environment for control. So I need to define policies and what policies has to be established in each and every account. Now I can do that easily with AWS Control Tower, where I control the policies centrally, and I establish guardrails, bare minimum security policies which my organization requires. I can enforce that on all the AWS accounts. Similarly, account management is very easy with AWS organization. If we have some cost control requirement, I can use AWS budgets, license manager, and other marketplace product. And similarly, because let's say if I design an application today, and tomorrow AWS is evolving at such a rapid rate, or such a fast pace, that every now and then there will be a new service, right? And believe me, the architecture which we followed back in 2012 is no more, recommended in 2020. So there has to be a continuous audit and a continuous review of your current architecture, so that we can ensure that we are using the best services which is offered by AWS. Right, so AWS is really evolving at a great pace, and so the review becomes very important, and we need to conduct review very frequently, maybe biannually or quarterly, right, so that we make sure that we're using the best services which is offered by AWS. Now operate with agility and control. So this is again an operational requirement. So operations want to operate with agility, and they want to control the applications, right? So that have certain requirements. So they want to monitor resources and workload, right? They have certain audit requirements. Operations, basically, if you have an operation team, they want to audit process configuration, user access policy info, and basically, right. Uh, Finally, they want a centralized dashboard where they can see what is going on, and they see into multiple account environment. So that's addresses following so with config, you will be able to see when a security group or an instance type family was changed. So with config, you can keep track. When changes happen to the source, can be tracked by it. Now manage resources and take operational action. When you detect any kind of incidents, you want to take actions, right? AWS system. So with system, you can write execute scripts remotely. Uh, Also about uh, landing and guardrails and for but was so I can default directory for so I can where you can integrate your on-premises activity, or you can create manage active uh, to all your all this account. This is also possible and supported. You can take actions. Automated remediations of non-compliant resources. This will happen through Lambda, so where you integrate with Lambda and take automated actions, right? Reverse those changes. If anything non-compliant happening in your resources, you can track it and reverse it automatically. This is also config. Now, finally, in summary, a lot of foundations here. Takeaways. That's fine. First thing, people design for for example, right? So we should really think from that perspective and services. Third takeaway is create build a platform, automate software delivery. So again, use CIC and create service provisioning. This is you can automate that which we saw in the previous slide. Create a security strategy, governance, and authentication. Have a centralized identity provider so that you can easily track what changes are happening inside your environment, right? So create a security strategy, governance a model, and then work on decentralized identity, right? And that's it from my side. So if you have any questions, please leave those questions in the chat box and I'll answer it. All right, Rakesh. So I'll just stop the sharing and
All right, that'll be all then. Thank you so much.
You're welcome, Rakesh.
Thank you for joining. Thank you so much. We'll end the session.
You're welcome. Bye, guys.